What is the shape of a normal, mature erythrocyte? So normal, mature, so we're looking at just the typical presentation, not the disease presentation, of an erythrocyte, which is another word for an RBC or a red blood cell. So we know that our red blood cells are shaped sort of like this. So you're like circular, and then we have this inner portion here. But not to be confused, when we draw it this way, that's not a hole. So we're not looking at sort of like a boomerang or some sort of wheel that has an inside here that would be completely missing. This actually is all one structure, but the inner part is sort of indented. So imagine that you have a piece of clay, right? And you kind of form it into this shape. So you roll up the piece of clay, you roll it up, you flatten it out. So now we have this flattened piece of clay. And then imagine that you have your finger and your thumb on either end of this clay. So we have like one end finger here, one end thumb there, and you press down, but not enough to actually break through. It's just kind of indented in. That's sort of how a red blood cell is, because it has that inner portion that's indented in, but not completely broken. So imagine sort of if you have a blow-up pool and how the sides are blown up and then the inside is indented in, but it's not completely broken. And imagine that if you turn over that pool, it's exactly the same on the other side. So it's completely symmetrical on either end, no matter how you flip it. That's how a red blood cell would be. So this type of presentation where you press in, but it's not broken, it has that indent, is like a concave. So it's like a well in and out, a well in and out. That's how a red blood cell would be. And that concave structure would be listed there, concave. And it's biconcave, because bi means two, and it's the same on both sides. It's not like it's just like this on this side. It's the same on either end. If you flip the red blood cell over, it's the same concaveness. So option B would be the correct option. We would not choose elliptical, because elliptical would be sort of like an ellipse without the concave structure. So it would just be like that. But that would not be an accurate presentation because it doesn't have that concave part accounted for in option A. Option C is spherical. So if we have just like a ball, there's some diseases that could cause that, but in a normal mature erythrocyte, that shouldn't happen. That would not be ideal. And then sickled, again, if it has a strange shape and it's hard to move, like in sickle cell anemia, that would be sickled. Not what this question's asking. So option B, biconcave, would be the correct answer.